Home Depot is pouring more into paint with fade resistance, scuff resistance, even one-coat coverage. This is the next generation of painting. Best paints, best brands, now even lower prices. The Home Depot. More saving, more doing.
Over 100 years ago, physicists were trying to figure out how things glow, like molten glass or hot lava. It seems like a simple question and was being pondered by such physicists as Lord Rayleigh at the turn of the 20th century.
I give you a wooden skewer that when touched to a flame glows orange-red.
Rayleigh knew that the color of this glow depends on temperature. Like the sun that has a surface temperature of 5,500 degrees Celsius radiates a bunch of different colors that together look white to us. Or me, at 37 degrees Celsius, I have this invisible halo of infrared light. Fun fact, infrared light is invisible to humans, but snakes can actually sense it from up to a meter away to detect prey. Rayleigh wanted to understand where the light came from and come up with a rule that would predict how much of each color it would emit. This is its spectrum. Another fun fact, Lord Rayleigh was the guy who figured out mathematically why the sky is blue. So Rayleigh thought of the simplest possible object, something that absorbs all light. Objects absorb, emit, and reflect light. Rayleigh's object would only absorb and emit, but not reflect. So all you would see when you look at it is its glow or its radiation. Physicists call this a black body. Technically, a black body isn't black, it's glowing, but whatever, physicists. A true black body doesn't exist in real life because nothing absorbs all light and radiates perfectly, although stars like the sun come pretty close. Kind of funny, right, that the brightest thing we know in our solar system is the closest thing we know to a black body. Physicists. Anyway, at that time, physicists didn't really understand atoms and molecules. They thought everything was made of particles that vibrate like springs. Rayleigh and his colleague James Jeans imagined a black body made of these vibrating particles where that vibration was continuously converted to light. From that model, they came up with a rule to predict what colors a black body would radiate at certain temperatures. But the unfortunate happened. Their reasoning implied that a black body should emit infinite amounts of ultraviolet light. They tried to apply their usual rules of Newtonian physics and came up with nonsense. We now call this the ultraviolet catastrophe.
Oh, Ivan Newton!
Something was very wrong with their work. A black body can't emit infinite amounts of radiation because that would violate laws of conservation of energy, and just from experience, when you put toast in your toaster, it doesn't promptly burn your toast to smithereens. When observation contradicts theory like this, it often means there's something missing in the theory. Rayleigh and Jeans had found a glaring error in physics theory. Bum bum bum! The same year that Rayleigh and Jeans published their work, a German physicist named Max Planck was studying radiation for a different reason. He wanted to understand why heat always flows from a hot object to a cold object. And in his quest to solve that problem, he unintentionally fixed their error. He assumed that a black body could only emit light in discrete quantities. Its energy comes in chunks, equal to the frequency of the light multiplied by this, a number we now know as Planck's constant. This is weird. It would be like if your faucet could only pour full glasses of water at a time. But when Planck assumed light was quantized, theory matched with observation. He solved the ultraviolet catastrophe. But here's the crazy part. Max Planck didn't immediately realize how big of a deal this was. Nobody did. He was just doing the thing that we all do with our math homework when your answer doesn't match the answer in the back of the book, so you just switch a plus for a minus, but you're not really sure why. Planck didn't understand what his work meant in the real world. It wasn't until a couple years later that Einstein realized that these packets of energy meant that light wasn't just a wave. It's made of particles that we now call photons. So then physicists started thinking about what this meant for atoms that emit those photons, and the theory of quantum mechanics began to unfold. Atoms emit photons when their electrons lose energy, and so their electrons must lose energy in chunks, in quanta. Quantum mechanics. The consequences of Max Planck's discovery that light comes in quanta, in packets, snowballed into what we now know as quantum mechanics. Quantum mechanics is bizarre. the microscopic world just misbehaves. Like, we're talking many billions of times smaller than the width of a human hair. For example, an electron can be in multiple places at the same time. In fact, an electron has no precise location. But the weird thing is, when you measure the electron, you find it in a specific place. It's like it has no location until you measure it. This popular image of an atom is wrong. Instead, most of the time it looks like a cloud of probability around the proton. This cloud of probability is the electron. Think about it. The particles that make up your body aren't a stack of solid objects. They're a collection of probability clouds. Quantum mechanics is unsatisfyingly unintuitive, but time and again it has proven to be real. Applied in computer chips, lasers, even LEDs. An electron probability cloud is only a nibble of the cookie. That is quantum weirdness. And after more than 100 years of study on the topic, there's still more to learn, which is why we're doing things like colliding particles at the Large Hadron Collider, just as a small example. I love this story because it shows how important it is to be wrong. Science isn't fixed facts and figures, it's constantly being modified and improved. Without Rayleigh uncovering this huge theoretical error that was the ultraviolet catastrophe, physicists may have never come up with the rules to describe a brand new, tiny, tiny universe. Thank you so much for watching, and happy physicsing!
I have something I need you to translate for me.
Is that... Lasers make things hot. Just think of all the lasers in sci-fi. Laser guns, lasers shooting out of your eyes, laser cutting, burning tumors with lasers.
And lasers can be used to burn your hair off.
Hey Derek from Veritasium.
Hey, Diana from Physics Girl.
So there's one more interesting use of lasers. and
What's that?
It's very different.
Uh-huh.
It's laser cooling.
Are you gonna keep going? Or do you want me to say something like,
You said just
what's
tell me
laser cooling?
So I first learned about laser cooling in college, and it was one of those moments where I just couldn't believe that the world works this way.
It's really counterintuitive.
This is how it works.
Okay, but before we explain how it works, we need to know what it means to be cold.
True that. Cooling something down means taking something like this and being like, cool down, man, chill out. And you turn it into something like this.
Right, so what Diana is trying to say is that the molecules in this boiling hot cup of water are moving much faster than in the ice. And so we are gonna try using lasers to slow molecules down. But that seems very strange because it seems like you're adding energy to try to decrease the energy of the system. That would be like trying to blow out a candle with a flamethrower. Just doesn't seem like it's gonna work.
Right, it sounds counterintuitive, but the thing about atoms and molecules is that they're constantly in motion, in this random motion. And in order to slow them down, you have to push them in the opposite direction of that motion.
Right, but you can't really grab them with your big macro fingers and slow them down.
So what you need to do is get down to their level using light. See, light has momentum in addition to energy.
Which is a weird thing, right? Everyone knows light has energy, but it also carries momentum, even without mass. That means if there's an atom moving in one direction and it absorbs a photon moving in the other direction, that momentum gets transferred to the atom and that will slow it down.
And that's the key to laser cooling. But you need a specific wavelength of light because atoms and molecules only absorb specific wavelengths of light. Just like this green balloon won't absorb light from a green laser, but this red balloon will, and it'll pop every time. It scares me so bad.
But once the atom has slowed down, isn't it just gonna keep getting hit by more photons and speed up in the opposite direction?
Well, this is the real genius of laser cooling. You want to make sure that your wavelength, the laser wavelength, is tuned to just longer than the absorption wavelength of a still particle, if the particle is not moving. So that way, when the particle moves toward the source, it sees that wavelength as blue shifted or squashed. And then it will only absorb the photon when it's moving toward the source.
Right, and then once it's stopped, the photon will just pass straight through. It's not gonna interact at all.
Exactly.
So that'll slow down atoms moving in one direction, but what if they're moving in all random directions, as they normally are?
Well, you add more lasers in the other direction. So if you got one laser this way, slowing down particles that are moving in this direction, well, you add another laser in this direction, another one top and bottom, front and back. So you've got 6 directions of lasers, slowing down the particles that might be moving in any combination of those 6 directions.
Do you need 6 lasers to make laser cooling actually work?
You need 6 lasers, or 3 lasers and mirrors on the side.
So in any direction they're moving, they will get hit with photons that slow them down. But once they're stopped, they no longer interact with the photons. That really is genius. How cold can you get these atoms with laser cooling?
Well, scientists have gotten down to microkelvins. That is millionths of a degree above zero. That's pretty close to absolute zero.
But of course, we're never going to quite get to absolute zero because of Heisenberg's uncertainty principle, which states that you can never know precisely the position and momentum of a particle at the same time, and so you can never really bring them to a full stop. They're going to always have a little bit of 0-point motion.
And for these really, really cold temperatures that we've achieved with laser cooling, like the microkelvins, that's for really small objects.
Didn't MIT get a gram of a substance down to a very cold temperature?
MIT got a gram down to 0.8 Kelvin, which is amazing. That's a macro scale object, which is incredible.
Right, and what would you use this stuff for? Like, why do you want to get it so cold?
If you want to look at a macro scale object and observe quantum behaviors in it, you have to get it extremely cold, and that's what laser cooling could be used for.
The other thing would be, I would think, atomic clocks. Like the ones in satellites, they have to be laser cooled to be really, really accurate. Otherwise, your GPS and your phone would not work. And so I think that's pretty cool that our ability to locate ourselves on our smartphones depends fundamentally on this mechanism, laser cooling, working in a satellite that is orbiting the Earth.
That's applicable directly to your everyday life. There you go. Laser cooling. One of the coolest uses for lasers.
They're pretty cool, but they can also be pretty hot, as I felt on my skin when they burned off my hair. Diana forced me to try out something called laser hair removal.
I don't know about the word forced, but it was a lot of fun. It was a great time. I got to watch Derek's hair singed off with a laser. We talked about the...
What about that does not sound like a great time, right?
We talk about the science of that over on Derek's channel, Veritasium. You should check out that video.
15 years ago, I bought a Fossil watch. It wasn't rated for
You might remember that almost exactly a year ago, there was a lot of buzz about one particular star. There were strange signals coming from this star, and no one was exactly sure what was causing them. Some people were even saying that the signals could have been caused by an alien civilization. Well, last week, the story got even weirder, because not only does the star's light flicker unpredictably, but it's been getting dimmer over time. This star is called KIC 8462852, and it's been nicknamed Tabby's star after Tabitha Boyajian, the scientist who described its weird properties and who Hank interviewed on SciShow in August. Tabby's star caught the attention of astronomers after it was observed by the Kepler telescope's exoplanet hunting mission. Kepler spots exoplanets by watching for stars that dim slightly as a planet passes in front of them. Most planets that it spots do this regularly, once every revolution around the star. But Tabby's star is different. Its light dims unpredictably at irregular intervals, and scientists aren't sure why. The most likely explanation is that a comet has recently broken up in front of the star, and dust and chunks of debris are obscuring our view at random. The far less likely, but way more awesome explanation is an alien civilization is using some kind of huge structure to harness the star's energy. Astronomers have been scratching their heads ever since this phenomenon was announced last year. Then in January of this year, another researcher announced that Tabby's star has gotten dimmer overall since 1890, based on old photographic observations. But as you can probably imagine, data collecting methods have changed a little since the 19th century, and comparing old photographic plates to new digital data could introduce some errors. In a paper being published by the Astrophysical Journal, researchers at Carnegie and Caltech checked into this claim using more recent data, the observations from Kepler over the course of 4 years. Kepler would check in on the star every now and then to look for changes in its light. Plus, because of the way Kepler works, it has to make a lot of observations to calibrate the camera and get a complete picture. So there are lots of observations made by the same instrument. The results were surprising. Tabby's star is dimming over time, the researchers say. Over the first 3 years of Kepler observations, it got darker by 1%. And that might not seem like much, but stars are huge, so that amounts to a whole lot of energy. Then, in the next 6 months, the star's brightness plunged by 2%. before leveling off for the rest of the observation period. A few of the other stars in Kepler's dataset got a little dimmer over that same period, but not so much or so quickly. If the star had only dimmed in the past 6 months, a comet or planet breaking up would fit the data really well. But 4 years of dimming is harder to explain, and the dimming might go all the way back to 1890. We've never seen another star act this way, and currently we don't have a good explanation for it. In other space news closer to home, Blue Origin, the spaceflight company run by Amazon CEO Jeff Bezos, has pulled off a pretty cool flight test, and it went way better than they expected. Blue Origin's New Shepard launch system consists of a crew capsule sitting on top of a booster rocket, and both the capsule and booster are built to be reusable. On October 5th, New Shepard passed a crucial test. The flight was aborted on purpose partway through the launch. That meant the crew capsule fired an engine to separate itself from the booster. Blue Origin intentionally picked a time, 45 seconds into the flight, where the spacecraft would be most difficult to control. The capsule used parachutes to land in the Texas desert, and it was recovered safely, which means the crew of a launch system like this could probably survive an accident mid-launch. As an added bonus, the booster survived too, and it wasn't really expected to. Blue Origin predicted that the capsule's escape motor would send the rocket into a death spiral, which is an acceptable loss when you're trying to save the crew. But the booster was fine and came back to land on its pad like nothing was wrong. So with 5 successful tests in less than a year, Blue Origin seems ready to get off the ground. As for New Shepard, it's flown 5 successful test missions and will now be retired. It's done its job of proving that Blue Origin can build a rocket that works, is reusable, and can pass safety tests. But it was also only meant for short flights that don't achieve Earth orbit. The next planned spacecraft, New Glenn, will have a lot more power under the hood. It's designed to be capable of orbital flight, and they plan to make even bigger rockets after that. Crewed Blue Origin test flights could happen as early as next year, and the company eventually plans to take private passengers too. No word yet on how much a ticket will cost, but you might want to start saving up. Thanks for watching this episode of SciShow Space News, and especially thank you to our patrons on Patreon who help make this show possible. If you want to help us keep making episodes like this, you can go to patreon.com/scishow, and don't forget to go to youtube.com/scishowspace and subscribe. Getting stuff off the Earth makes it almost impossible for lots of countries to do science in space, but many of them are about to get their first shot. At the International Astronautical Congress last week, the United Nations
Germany, 1939. In a secret bunker on the German-Polish border, Nazi agents were overseeing the production of a recently discovered chemical they'd codenamed Substance N. It boiled when they exposed it to air, it exploded when it touched water, it was lethal when inhaled, and when it decomposed, it spit out deadly hydrofluoric acid. When loaded into a flamethrower and ignited, it could burn at temperatures over 2,400 degrees Celsius. The plan was to arm troops with Substance N and use it to melt Allied bunkers into hot porridge. But then after studying it for a while, even the German soldiers were like, whoa. Experiments with Substance N were discontinued because the Nazis decided it was too dangerous to work with. Should give you some kind of sense of what we're dealing with here when we talk about the most dangerous chemicals in the world. I'm talking about things that explode when you touch them. Things so poisonous that if even a millionth of a gram went up your nose, it would end up killing you. Things that could even disable you because of their totally debilitatingly horrifying smell. And yes, chemicals so severe that even the Nazis thought they were crazy. Let's start with what the Germans had in that secret weapons bunker. They originally planned to produce 90 tons of the stuff every month, but only made about 30 tons throughout the whole war. What they'd concocted was chlorine trifluoride, the most vigorous fluorinating agent known to humanity. Fluorinating agents rip other molecules apart to replace their hydrogen atoms with fluorine. The result is what chemists call a violently exothermic reaction, in this case known as a fluorine fire. It's much more dangerous to handle than even fluorine gas, which, as anyone with a degree in chemistry could tell you, is not a sentence that you get to say very often. It's also a better oxidizer than oxygen. Oxidizers are compounds that steal electrons from other chemicals in a reaction, and they are what make combustion possible. Chlorine trifluoride is so good at this that it can burn stuff that sane people might think of as non-flammable, like bricks or asbestos, or things that have already been burned. Oxidizers are also used to ignite rocket fuel, and in the very short time that US rocket scientists thought about using this stuff as a propellant, they quickly learned that this idea was bad. In the early 1950s, the first time that US scientists tried to ship chlorine trifluoride in bulk, the steel tank cracked and a full ton of it spilled out. It burned so hot that the chemical ate through an entire concrete floor, and then a meter of dirt and gravel beneath that. One eyewitness described the spill only by saying, "The concrete was on fire." Chlorine trifluoride is still manufactured and is used by semiconductor companies to clean their equipment to within an inch of its life. The good news is that you can store it safely in a regular steel drum, as long as it's airtight and you're really, really careful, because it instantly scorches the inside lining of the container, leaving behind a non-reactive plating of metallic fluoride. Non-reactive is not a word that we're going to need when discussing the next chemical on our list, azidoazide azide, the most explosive chemical compound ever created. This twitchy little compound is part of a class of chemicals known as high nitrogen energetic materials, and it does what it does because nitrogen just wants to be left alone. A nitrogen atom bonded with another nitrogen atom is one of the most stable molecules on Earth. Their electrons form an extremely strong triple bond with each other, which in nature can usually only be broken by a molecule being hit by lightning. The strength of that bond means that when two nitrogen atoms snap together, they release a tremendous amount of energy. So if you look at a molecule of AA, we're going to call it AA because azidoazide azide is hard, you can see how it gets its bang. It has 14 nitrogen atoms, and because of the way the molecule is structured, none of them are in a triple bond. Instead, they're stuck in a loosely bound high energy state and are dying to move to a more stable lower energy state, which means releasing a lot of pent-up energy in the process. As a result, AA is both highly reactive and hecka explosive. How sensitive is this stuff? Well, it's actually hard to say because it's too sensitive even to measure how sensitive it is. A team of German chemists created it in 2010 with the help of the US Army in an effort to develop more energetic compounds. And their first report on the discovery, they said, and I quote, "The sensitivity of C2N14 is beyond our capabilities of measurement. Even the smallest possible loadings in shock and friction tests led to explosive decomposition." To give you a list of how touchy this stuff is, here's a list of things that make azidoazide explode. Moving it, touching it, dispersing it in solution, leaving it undisturbed on a glass plate, exposing it to bright light, exposing it to X-rays, putting it in a spectrometer, turning on the spectrometer, and my favorite, absolutely nothing. They had it in a shock-proof explosive case in a dark climate control room, and it blew up. I think somebody said something mean about it somewhere, and it was like, the lead scientists on the team that synthesized it called it a very exciting discovery. If I worked with azidoazide azide, waking up every morning and seeing that I still had all my fingers would be a very exciting discovery. Next up, let's talk about dimethyl cadmium. This is an organometallic compound, which means that it has a molecule in which carbon has bonded with a metal. In this case, that metal is cadmium, a pretty nasty customer all on its own. So far, we've talked about chemicals that explode or cover everything in unquenchable fire. And don't get me wrong, dimethyl cadmium, it does that too. But that is not what makes it so dangerous. It is, in all likelihood, gram for gram, the most toxic chemical in the world. It has both acute and chronic effects, which means that it will kill you now and later. It was first prepared by a pioneer of metal organic chemistry, a fellow named Erich Krauss, who was from, yes, Germany. It was 1917. To give you a sense of how Krauss rolled, he died in his lab at the age of 37 after accidentally inhaling a bunch of chlorine, but before that happened, he managed to report his discovery of dimethyl cadmium. When you breathe it in, it is absorbed instantly into your bloodstream, where it basically serves as a kind of chemical chauffeur for toxic compounds of cadmium to travel all around your body. Because it's so effective at exploiting your bloodstream, it quickly affects your most blood-infused organs, like lungs and your kidneys and liver, creating compounds that rip electrons off the atoms of your cells. But if you manage to survive your first few hours after dimethyl cadmium exposure, don't get your hopes up. It's also extremely carcinogenic, so it will take you down with cancer just to spite you. This stuff is so potent that as an airborne vapor, just a few millionths of a gram per cubic meter of air meets the legal safety limits. But if you spill it, how are you gonna clean it up? Water? Well, when it reacts with water, it produces both lots of heat and lots of hydrogen gas, which is flammable, so yeah, it explodes in water. Maybe you can sweep it up? Yeah, friction makes it ignite. Might wanna just try waiting for it to decompose? Well, it will do that. It'll form a crust of dimethyl cadmium peroxide, which is a friction-sensitive explosive, so you're just one shoe scuff away from kablamo. And on top of it all, the chemical has an odor that's been described as foul, unpleasant, metallic, and disagreeable. But that's nothing compared to our next chemical, thioacetone. It won't explode or start fires or even give you cancer. Compared to other chemicals on the list, it's like a cute little fluffy bunny. If that cute little fluffy bunny had the most ungodly stink you can imagine. That's right, thioacetone takes the prize for the world's smelliest chemical. It's a thiol, an organic compound in which a carbon atom is bonded to a sulfur-hydrogen pair. They're all gross. A skunk spray uses 2 different thiols to eye-watering effect. Most sulfur-containing compounds are released by rotting meat, which is a reason why we would want to be very good at being able to detect them and also not think that it smells good. But when it comes to bad smells, thioacetone takes the stinky, seriously unappetizing cake. You can smell 1 drop of this substance almost instantly from half a kilometer away. In the 1960s, a vial of the stuff fell off a shelf in a research lab. People were chucking their cookies in buildings 200 meters away. But the greatest example of thioacetone's silent but deadly strength comes from the German city of Freiburg, where in 1889, chemists at a soap factory were reportedly working on a larger molecule known as trithioacetone, which is used as a flavoring and a fragrance. But when they broke it apart into thioacetone, workers started falling ill. Spontaneous outbreaks of vomiting were reported in the surrounding neighborhoods. It led to the evacuation of the whole city. There might be a lot to learn about thioacetone and thiols in general, but understandably, scientists are not really rushing to look into it. And finally, there's the strongest corrosive agent in the world, the most dangerous acid ever devised by humanity. Fluoroantimonic acid. Because what list of dangerous chemicals would be complete without a superacid? What makes an acid is its ability to donate a proton to another molecule nearby it. And a proton is just a hydrogen atom that's lost its electron. This process is called protonation. And an acid's strength is determined by how willing it is to give up that proton. A weak acid, acetic acid for example, which is just the undiluted form of vinegar, will drag its feet about protonating other molecules. Most of it will just sit there doing nothing. But a strong acid, like sulfuric acid, will punch that proton in the air like a beach volleyball at spring break. And remember from Substance N how crazy fluorine is? Well, fluoroantimonic acid is 10 quadrillion times stronger than sulfuric acid. This molecule is begging for an excuse to fly apart. Once it's lost its hydrogen atoms, the remaining atoms of fluorine and another element, antimony, tear through everything else around them, ripping electrons off nearby molecules and leaving just organic goo in their wake. Especially exciting is that fluorine really likes to bond with calcium, so once the acid tears through the fatty organic tissues of your skin and muscles, the fluorine will burn through your bones. The only way to store fluoroantimonic acid is in Teflon containers. Teflon, by the way, is held together by carbon-fluorine bonds, which are the single strongest bond in organic chemistry. We don't actually know a lot about this acid because it's so hard to do experiments with it. You can't put it in a syringe or on a slide. It eats through glass like it's cotton candy. You can't put it under a fume hood. It'll eat the fume hood. All you can really do is just look at it, ideally from very far away. Thank you for watching this particularly dangerous SciShow infusion. Thank you especially to our Subbable subscribers who help us make this show for them and for everyone else. To find out how you can support us, you can go to Subbable.com. And if you want to keep getting smarter with us, you can just go to YouTube.com/SciShow and subscribe.
Getting real sick of this crap.
Let's suppose that you're...
Let's not.
Pilots are cordially reminded to observe facility traffic regulations and avoid obstructing the airlock.
Since its invention in 1826, for hundreds of years, photography has been used as a way to capture a moment in time, a memory of a past event, a family, or another special moment. But some pictures taken have captured more than they intended. The following images I'm about to show you were all taken by regular people who captured some extraordinary things. Things that are hard to explain, things that perhaps should not exist. And in case you're wondering, the vast majority of these photos were taken decades before the invention of Photoshop, or for that matter, before the first computer. The rest were phenomena that were observed and validated by hundreds or even thousands of others. But it's up to you to determine what you make of them. So, without further ado, here are 10 mysterious photos that should not exist. Number 1 are the Phoenix Lights. On March 13th, 1997, two distinct events occurred over Phoenix, Arizona and Sonora, Mexico that were seen by thousands. Two separate light formations formed in the sky. One, a triangle that was created by 3 separate lights, which slowly passed over the state, and the other, a line of stationary lights. Now, normally, lights in the night sky are not a cause for alarm, except that stars disappeared and then reappeared behind the dark mass in the sky. Because of the outcry from the public, the US Air Force was actually forced to respond and explain that these events were simply flares and training exercises. But perhaps most interestingly, the governor of Arizona at the time, Fief Symington, mocked the idea of the lights being of alien origin, except that several years later he admitted that he saw the lights and said that he believes that they are otherworldly. Number 2 is the ghost baby. In Queensland, Australia, in 1945, a mother named Miss Andrews went to visit the grave of her late daughter and decided to take a photograph of the gravestone. Upon developing the image, she noticed the ghostly image of a young child staring right back at the camera. Now, Miss Andrews didn't recognize the child as her own daughter because her daughter died at the age of 17, much older than the apparent age of the infant. However, perhaps what is most chilling about this is that a paranormal researcher went to that very grave to find a possible explanation for the picture and found a nearby grave dedicated to 2 infant children. To this day, there is still no explanation as to the apparent apparition in the image. Number 3 is the specter of Newby Church. In 1963, Reverend K.F. Lord took numerous pictures inside of a church in North Yorkshire. Upon examination, one photograph appeared to have an artifact. Now, photography at the time was not perfect, so many pictures often had artifacts. However, this artifact appeared to resemble a human. The image appears to show a hooded person standing right in front of the altar. While many experts have tried to determine whether or not this is double exposure, most speculation has concluded that it resembles a 16th century monk with a white shroud over his face, possibly to mask leprosy or another disfigurement. And even more strangely is that in relation to the nearest furniture, the figure would measure nearly 2.7 meters tall, clearly not something of this world. Number 4 is the Hampton Court Ghost. For nearly 200 years, a ghost has been rumored to have haunted the corridors of the Hampton Court Palace in London. However, over that time, nobody has been able to capture and picture the alleged form. Until now. In 2003, emergency doors in the Hampton Court Palace were mysteriously opened 3 days in a row. On the first and third day, cameras captured what appeared to be the doors opening by themselves. However, on the second day, they captured something entirely different. A ghostly figure believed to be Dame Sybil Penn. She was a servant at Hampton Court to 4 Tudor monarchs and the nurse of Prince Edward and Elizabeth I until she died of smallpox in 1562. Hampton Court, home of Henry VIII and many other royalty, has long been famed for its ghosts, but this was the first time that an image of one has been captured in hundreds of years. Number 5 is the Hook Island sea monster. In 1964 in Australia, French photographer Robert Surek was spending time with his family boating off the coast of Stonehaven Bay. Suddenly, Surek's wife noticed a large tadpole-like creature under the water. This is the picture of the 24-meter-long creature, which, according to him, appeared to have a wound on its back. Almost as if knowing that the creature was having its picture taken, it swam away with blazing speed, never to be seen again. Number 6 is the Naga Lights. This picture is of Thailand's Mekong River. The phenomena shown are known as the mysterious Naga Lights, basketball-sized balls of fire that shoot from the surface of water hundreds of meters into the sky and then vanish. Their occurrences of no debate as they have been photographed and witnessed by tens of thousands of people over the years. However, what is mysterious about them is why they occur, which currently has no scientific explanation. Now, some theories suggest phosphine gas or free-floating plasma orbs similar to those in plasma physics, or some other naturally occurring event, but to this day, still, nobody has an explanation for them. Number 7 is Freddie Jackson's ghost. This picture is from 1919 of the crew of the HMS Daedalus during World War I at their training facility. It was a somber day as just 2 days prior, a member of their team, air mechanic Freddie Jackson, had died accidentally by an airplane propeller, and his funeral was earlier the same day that this photo was taken. But once it was developed, however, something very odd was immediately noticed. There was an extra face among the men, a face that the men recognized. The face of air mechanic Freddie Jackson. Remember that this photo is from almost 100 years ago, and most versions online are cropped and altered in some way, but what you are looking at right now is the original unaltered scan of the original photo. As you can see, there's Freddie in the back row smiling, as if unaware that his own death had taken place just 2 days prior. Number 8 is the McMinnville UFO. This photo is often considered among the most famous UFO photos ever taken. Known as the McMinnville UFO photograph, it was taken on a farm near McMinnville, Oregon in the United States in 1950. That same year, Life magazine, along with several newspapers, reprinted the photo, which many ufologists consider to be genuine. The photograph shows what looks to be a tilted underside of a UFO flying through the sky. Now, skeptics suggest that it could be a possible speck on the lens, as cameras back in those days weren't quite as HD as they are now. But to this day, nobody knows for sure what this image means or what it's of. Number 9 is the SS Watertown ghosts. In 1924, 2 men working aboard the SS Watertown oil tanker, James McCourtney and Michael Meehan, were both accidentally killed by a gas leak during travel at sea. Soon after, the men were given a respectful burial at sea. But the other crew members began noticing something mysterious as they were conducting their duties. In the days to follow, crew members swore that they saw the faces of the 2 men in the waves. In response to this, the captain took a series of 5 photos, 4 showing nothing unusual, until the 5th, which showed this, what appears to be the faces of James Courtney and Michael Meehan. To this day, neither the crew, the captain, nor anyone else aboard have any idea or explanation for what the apparitions appear to be. And number 10 is the Brown Lady of Raynham Hall. In 1936, a professional photographer working for Country Life magazine took pictures within the Raynham Hall in Norfolk, England. In one such picture, he managed to capture this ghostly image of a woman on the stairs. What's eerie is that just a year earlier in 1935, reports from guests staying in that hall claimed to have seen a ghostly figure floating through the corridors with her eyes gouged out, wearing a brown dress. Immediately, those who worked there realized that this picture matched the description given. It's believed that the apparent apparition is of Lady Dorothy Walpole, the sister of Robert Walpole, generally regarded as the first Prime Minister of Great Britain. Before her death, she was trapped there, locked away in the hall as punishment for adultery until she died painfully by herself from smallpox. Once again, another photograph with no explanation from anyone involved. So, those were 10 mysterious photographs that likely should not exist. But I want to know from you in the comments, do these photos have a reasonable explanation, or should they simply not exist? I also want to give a big thank you to Audible for sponsoring this video. They have an unmatched selection of audiobooks, original shows, and more for nearly all devices like iPhones, Androids, iPads, tablets, etc. Audiobooks are truly the perfect way to pass the time, especially when you're doing something time-consuming like traveling or simply doing chores around the house. And Audible is offering a free audiobook with a 30-day free trial to give you a chance to try out their service if you use the link in the description. Audible.com/Matthew. Lately, I've been listening to The Book of Mysteries by John Kahn, and I can tell you it's very thought-provoking, so I recommend that you check it out. So go get that or another audiobook for free along with a 30-day free trial at audible.com/Matthew right now. Thank you guys so much for watching, and just a reminder, if you are subscribed to my channel, be sure to click the little notification bell beside the subscribe button
control.